My name is Jacques Duplessis and I am going to take a lovely journey with you tonight into some serious maths. We're going to do some geometry, we're going to do some trigonometry, and then two calculus questions. But before we start, folks, let us have a loud shout out for Liberty, for sponsoring the show and for making it possible for us to do this work. Liberty, thank you, thank you, thank you. Okay, let's start and let's look at what I've got on the screen. It's a grade 11 geometry question that Shannon Zorab has given to us to do. So I am going to read you through what the question says in the book. And as I read, folks, I want you to follow me on the screen and see what do I do as I read important things. The first thing says, in the diagram below, triangle ABC is drawn in the circle. Now, folks, if they told you triangle ABC, let's just quickly tell you what that means. If they call something a triangle, they are telling you it's a polygon, okay, without saying that. Why is that important? Because a triangle is made up of three connecting line segments. Okay, and a line segment is straight. Why is that important? Let's look on the diagram here. I might need to say that here at angle K, I have three angles that are adjacent to one another, and I might want to use this as 180 degrees. I cannot do that unless I have read that this is a line segment or a chord, or other ways to tell us that that is straight. Okay, so let's read on. Let me just get rid of that last arc I drew. There we go. TA and TB are tangents. Now, if TA is a tangent and TB is a tangent, they come from the same external point. So immediately, grade 12s, and if there's any grade 11s watching, you can say that those two sides are indeed equal, which as a consequence makes this angle at A3 equal to that angle at B2. But I'm not finished. I'm not finished with the idea of a tangent. Now remember, your tangent theorems, the radius is perpendicular to the tangent at the point of tangency on the circle. The angle between the tangent and the chord is equal to the angle in the alternate segment. That's your second tangent theorem. The third tangent theorem is the one I used, that if you have tangents drawn to a circle from the same external points, those two tangents point, not points, from the same external point, those two tangents are equal in length. Okay, so we've used that theorem. Let's go and see if there's a Tan Chord theorem. There's the tangent is TB, the chord is BA, so the angle between TB and BA is angle B2, which is equal to this angle C here at the bottom. Okay, so those three angles so far are equal to one another. Now, if you look at the angle here at A3, it's also equal to the angle at C. We don't have any radius or any diameter given to us, so we can't use the fact that the radius is perpendicular to the tangent. Let's read on. What do they say? They say the straight line THK, all lines are straight, so the line THK is parallel to AC. Aha! THK, this line here, is parallel to AC. Now, folks, you can see I translate my English that's in that little paragraph. Every geometry sum comes with that little paragraph written at the top of it. You read that paragraph. That is your landmark that you have got to turn into symbol language on the diagram. Okay, excuse me. So TK is parallel to AK. Now that means, look at this, that this angle at K3 is equal to the angle at C. Well, why am I saying that? Those two lines are parallel. Here's the transversal BC. So those two are corresponding angles that are equal to one another because of the parallel lines. Okay, let's see if there's anything else. Oh, look at this. We can also say, let me use another color. We can also say that the angle K2 is equal to the angle A1. And that is because they are alternate angles, AK being the transversal in this case. Okay, I'm happy so far. Very happy. Let's read on. They now say to us, THK is parallel to AC and H, with H on BA and K on BC. Okay, we've seen that. And then they tell us AK is drawn. And lastly, that A3 is equal to X. Okay, so all of these little green angles will be X's. There we go. That's an X and this is an X because they told us that A3 is X. Now, folks, that is what's in the paragraph, okay? If there are any cyclic quads in this diagram, remember they don't have to tell you it's a cyclic quad. If there are 4 points on the circle, it qualifies as a cyclic quad, okay? And then you can bring in your cyclic quad theorems. There are unfortunately only 3 points on this circle, so we don't have a cyclic quad. So let's see what they ask us. Before I go there, folks, please, I'm telling you again, that little paragraph, I know you can't see it, but you know that before every geometry question, there's a paragraph with information. That is the most important thing that you read and that you fill in onto your diagram, and only after you've spent 3 to 4 minutes coloring in your treasure map do you go and look at the questions. Most of the time, if you do the coloring in and the symbol language in your diagram correctly, folks, you do not have to think a lot. Your answers will already be on the diagram. Let's see if that is indeed the case here. Okay, they're asking us to show that K3 is equal to X, and look at that. We've done our job properly. K3 is equal to X. How did that happen? This is now where you do the mental gymnastics, folks. You think back about where did it start? It started with the tangents. The tangent was our passport into that triangle on the inside. And then, secondly, the parallel line. Because those lines were parallel, the angle between the tangent and the chord and the angle in the alternate segment was linked. The angle in the alternate segment was linked to the angle that lies above the parallel line. Corresponding angles. Now the question is, how do we write this out? Let's see. We're going to start by saying, let's start with A3 for number 1. Angle A3 is equal to angle C is equal to X. Why is that so? This is the Tan Chord Theorem. You have to give reasons, folks. So A3 is equal to C. AC, the line, is parallel to TK. Why is that so? Well, that was given to us. Okay? And here's the step where we connect the two. Angle C is now equal to this angle here at the top, which is K3, and is therefore equal to X. Why is that so? They are corresponding angles that are equal to one another. Why are they equal? Because the lines were given as parallel. Okay, that was for how many marks? For 4 marks. Okay, so you're going to get marks for your reasons, and you're going to get marks for your statements. So make sure that you state this clearly on your diagram. Okay, the next one. Prove that, let's just go back here. No, we don't have to go back. AKBT is a cyclic quad. Now, it should already be one if we did our job properly in the beginning. Let's have a look. AK, I'm going to make their dots there. AKBT is a cyclic quad. And I'm sure you are all shouting out at home. It is because A3 became equal to K3. Look at this. With A3 over here equal to K3, both those angles are subtended by this tangent at the top, TB. So in that quadrilateral, angle A3 is subtended and K3 is subtended. So they want us to say for 2 marks why that is the case. So all we're going to say is, hang on, we've just shown that A3 is equal to K3. They're both subtended by the line BT, hence it's a concyclic figure. Let's write it out quite nicely here at the bottom. Number 2, A3 is equal to K3 is equal to X, proven above. Okay, that was the first thing we did. A3 became equal to K3. These angles are both subtended, subtended by tangent, I think it was tangent TB. Yeah, tangent TB. Now, if the angles that are subtended by a line are equal, we have that AKBT is a cyclic quad. Why is that so? Angles equal. Angles, let me rewrite this reason. Where's my green? Equal angles subtended by chord in this case or tangent TB. Okay, but that's for 2 marks. So it's the connection we made between angle A3 and K3. Now folks, let's go back to the diagram. We've just shown something very important. We've shown that this figure AKBT is a cyclic quad. Now look at what's going to happen now. Because this is a cyclic quad, I can now say that B2 is indeed equal to K2. So this is also an X. Why is that the case? Well, they are subtended by this chord of the cyclic quad or by this tangent TA. So the orange ones, I'm going to scribble over them in the same color as that, and I'm going to make them X's. Okay, let's see what else. This little angle at T2, if we need it, is equal to the angle at A3 because they're both subtended by BK. And I'm just going to put a dot here, or let's put a line with a dot on it for T1, which is equal to B1 over here. We can also use another color. I think let's make that dot orange on the green so that that stands out for us. And that's not all. That's not all. We are filling in everything, every single theorem that we have on a cyclic quad. Let's quickly run through them. Opposite angles are supplementary. Angles in the same segment are equal to one another. And the last one, which I'm going to look for now, is the exterior angle equal to the interior or the opposite interior angle. Let's have a look. They told us that BC is straight. So this little angle here at K1 is an exterior angle to the cyclic quad and is therefore equal to this full angle here at the top. Exterior angle of a cyclic quad. Okay, that came from just proving that that is indeed a cyclic quad. We could fill in all that additional information. Let's look at the third question. The third question says, prove that TK bisects angle AKB. Let me just move that green away for us there. Angle AKB. Now, if we go to the diagram, AKB here is nothing else but angle, so AKB, angle AKB is angle K2 plus angle K3. Now, to show that that angle is bisected, we need to show that K2 is equal to K3. And look at your diagram, folks. They are both equal to x. In fact, they just became equal to x once we had the cyclic quad. Okay, so we saw now that K2 became equal to B2. Why? Angles in the same segment. So that's where our argument is going to start. I'm going to go down, and I have to go up and down here for a while to get back to my diagram. So we said that angle B2 is equal to angle K2. Angle B2 is equal to angle K2 is equal to x. Why? Angles in the same segment are equal to one another. Okay, that was a cyclic quad. But then we also said earlier on that angle A3, which is equal to B2, is also equal to K3. So A3, let's write this down, angle A3 is equal to angle K3 is also equal to x for the same reason, the angle in the same segment. That's all we have to say. Now we connect them via angle A3 and B2 that are equal to each other. So we say, but A3 is equal to B2. Why is that so? They are angles opposite equal sides. Why are they angles opposite equal sides? Because these two tangents are equal to one another. TA is equal to TB because they're both tangents. And we can then conclude, our final conclusion will then be, therefore, that K2 is indeed equal to K3, which means that TK does bisect the angle BKA. And that's what they wanted us to prove. Okay, so folks, remember, you've got to, there's a nice word in Afrikaans that said, hou kop. Okay, keep everything together. Keep your eye focused on what is important in this diagram. Okay, keep your marbles together when you do geometry, folks. Let's look at the next one. TA, they want us to show that TA is a tangent to the circle through AKH. Now, if we look at that, AKH does not have a tangent here, or doesn't have a circle. There's AKH, that little triangle over there, does not have a circle around it. Okay, but they say, prove that if there was a circle around it, TA will be a tangent. Now remember, the only way you're going to prove that is one of your tangent theorems. And my suspicion is that the Tan Chord Theorem is going to tell us that. Let's have a look. We already know that A3 is equal to K2. Okay, they're both equal to x. That's the point. There's the tangent. The TA is our tangent. AH is our chord. The angle subtended is K2. Okay, so all we need to say is that K2 is equal to A3. K2 over here is equal to A3. Okay, and if you want to, you can say they both equal x, or we've proven above. One of the two. Okay, but that's the point. Therefore, TA is a tangent, and the short way to write tangent is TGT, to the circle that can be drawn around A, H, and K. Why is that so? Well, this is converse Tan Chord Theorem. Okay, so we're applying the Tan Chord Theorem in reverse. That's what the converse means. If those angles are equal, then it is a tangent. The straightforward is if it's a tangent, those two angles have relationship. Okay, let's look at number 5 here. Number 5 says S is a point that lies on the circle where ASKB is a cyclic quad. Okay, now I'm going to need another color. S is what we're referring to, and we're talking ASKB. Now, ASKB is the figure that we're talking about, that blue figure. Now they say that is a case. Is ASBT concyclic? They're telling us this is a cyclic quad. They say it is a cyclic quad. Then they're asking us, and let me go up a little bit, is ASBT, is that a cyclic quad? Is the question that we have to answer now. Okay, folks, so let's see how we're going to answer this. I'm going to talk you through it by looking at the diagram, and then we can write it out. If ASKB is a cyclic quad, then we know that opposite angles in this cyclic quad are indeed supplementary to one another. So if we look at BSA, let me just say ASKB. If we look at angle BKA, in other words, that angle there, which we have as 2x, okay? This is an angle, and that the size of that angle, let me color the whole one in blue, there is 2x. So what does that mean? We now have to argue, because this here, the blue one, the blue figure that we're working with, they told us is a cyclic quad. We must say something about the angles that are lying in this figure, this cyclic quad over here, the blue one. Now we can also use the fact that these are angles that are supplementary to one another. Okay, now let's see how we're going to make use of that. Remember, this orange angle here was equal to that angle over there. Now, if this is to be a cyclic quad, then we've got to show that this is 180 minus 2x. Okay? Now, if we look at this, here we have the exterior angle, which is equal to the interior opposite angle. So this little angle here, which lies outside here, we don't even need it, folks. We need to work with this full angle over there. If we look at that full angle, that angle here is indeed 180 degrees minus 2x. Okay, we're wanting to see, is ASBT a cyclic quad? So I'm going to draw this line in another ASBT. There we go. ASBT. I wish I had a highlighter. Let me just see if I can find my highlighter. Let me use this yellow one. I'm going to do this with it. There's such a lot of lines here now. ASBT. Now you can see it better. That's much, much better. Okay, so because this here is a cyclic quad, I can say that this angle here at the bottom is also 2x, because angles in the same segment are indeed equal in the blue one. Okay, now I need to show that this is a cyclic quad, but if that is 2x here, okay, we've got that as a cyclic quad, the big one. ASBT is what we're looking for. We've got this as a cyclic quad over here. So this is 2x, and that's the angle that lies opposite to it, which is 180 minus 2x. Now, if that's 180 minus 2x in the new cyclic quad, the angle opposite it is indeed 2x. That was, I think, for a good 4 marks that they asked this. So I'm going to talk you through it. We're not going to write it down. I'm going to talk you through it quickly. Okay? We've got ASKB, which they just told us is a cyclic quad, which means that this angle over here is equal to that angle over here. That angle together was 2x. So this is 2x. So for this yellow one to be a cyclic quad, this has to be 180 minus 2x. But we cannot say that it is, because we need to work through the other cyclic quad, which is this one over here. The cyclic quad we had right from the beginning was that one. Now that's 2x. So for this green cyclic quad, the angle opposite to it is 180 minus 2x, which happens to be that whole angle. Point proven. Okay. Folks, you can see my diagram looks like a battlefield. That's how you do geometry. Your diagram must be full of so full of information. Use different colored pens, but buy yourself thin colored little pens, just 4 or 5 colors, and buy yourself highlighters so you can highlight the figures that you're working in.